Good morning, Year 6. I hope you had a fabulous weekend and you're ready for a week of learning. It's going to be our last week on algebra. Next week is half term. So can you write down today's date, 18th of May 2020, and the LI, which is to form simple expressions. For today's lesson, you will need a pencil, a paper, and a 5-minute timer. Check. So before we go on to today's lesson, last week we explored one-step and two-step function machines. So today we're going to be looking at how we can use these to help us to form simple formulas. So if you haven't done the lessons last week on function machines, then you need to make sure you've completed them before going on to today's lessons. Now we're going to go on to our starter. So just as we usually do, I'd like you to pause the video here and set your 5-minute timer and off you go. However, if you would like some more help, then I would suggest that you pause the video after I've shown you some extra resources on screen to help you answer these questions. So, we have a place value grid. This should help you with the place value question as well as the calculation and algebra question. Making sure you've lined up the digits correctly will help you to read the numbers and also help you to add them correctly. I've also got some tips for the fraction section. So if you know what you're multiplying by, then that will help you to find the equivalent fraction. And that's all I've got to help you at this point. So I'd like you to pause the video here whilst you have a go at the questions on screen. Fantastic. Now let's go through the answers. Write the number shown on screen in words. So that should be written as 7,040,210. Making sure that you spelt 40 correctly because 40 is naughty as it drops the U. So making sure you've got that written correctly. If you have used the place value grid to help you here, then you should make sure that if you've lined up the numbers in the correct columns, then that makes it a lot easier for you to be able to read. And again, using that same place value grid, we should be able to add the numbers using column addition. So 1,583,140 plus 593,587 equals 2,176,727. So well done if you got that. Now for the fraction section, 6 times what makes 24? Well, 6, 12, 18, 24. 6 times 4 equals 24. So therefore, whatever we multiply the denominator by, we need to multiply the numerator by. So 6 times 4 is 24. So 5 times 4 is 20. So 20 24ths is equal to 5 6. Now we go on to problem solving. We have to write a multiplication calculation to match the bar model. So if we've got 3.42 is our total, we know bar model, the number shown on top reflects the total amount of all of the values at the bottom. So if we've got 3.4 at the top, then 1.14 plus 1.14 plus, what's the missing value? 1.14. We know that because all of the boxes look like they're an equal size. And if we add them together, then if we add together 1.14 three times, we'll get 3.42. So we know that that missing value is 1.14. But that's not the question. The question is asking us to write a multiplication calculation to represent the bar model. So what you should have written is 1.14 times 3 equals 3.42, or 3 times 1.14 equals 3.42. If you've written 3.42 divided by 3 equals 1.14, you are wrong because you had to write a multiplication calculation to represent the problem. So if you've written division or repeated addition, then you're not quite right. Now, Harry. Harry says a cube has a volume of 8 centimeters squared. Each face has an area of 4 centimeters squared. Now, if you look at the cube shown on screen, what do we know about a cube? We know that a cube has all of its lengths are the same size. Every edge is equal in length. So Harry has said that the area of each face is 4 centimeters squared. So if the area is 4 centimeters squared, 4 would be our square number. So what would be the square root of 4? Fantastic, it's 2. So now we know that the length of each side is 2 centimeters because 2 times 2 gives us 4 centimeters squared. But in order to find the volume of a cube, we have to multiply the length by the width times the height. So length times width times height. If we know that each edge is worth 2 centimeters, then 2 times 2 times 2 equals 8. Super. So we do 2 cubed, which gives us 8 centimeters cubed. But Harry has said it's 8 centimeters squared. So Harry is wrong because he's forgotten that when we're finding the volume, we're multiplying 3 dimensions, not 2 dimensions. So therefore, it should be 8 centimeters cubed. Well done if you managed to get those. So today we're going to be looking at expressions. Expressions are a mathematical formula which expresses the relationship between two unknown values. This function machine is an example of a formula as the output value is dependent on the input value. So you remember we've been looking at function machines so much over the last week, and we can see that it's dependent upon the input value. The input value will determine what the output value will be. So a formula is something which expresses the relationship between two unknown values. So you can see here our first question mark, we don't know what the number is. Second question mark, we don't know what the number is. So it tells us what is the relationship between them. And we know that the question mark shown in the green circle has a value of 35 more than the number shown in the orange circle. In algebra, letters are used to represent unknown values. Any letter can be used to represent an unknown value. Okay, so we can use the letter when we don't know how much something is, we use a letter instead to represent it. When a letter is used in algebra to represent an unknown value, it is called a variable. Now I want you to have a go at saying that word, variable. Excellent. So here, our variables here are A and B, because they are letters that are being used to represent a value which we do not know. Any formula can be written down as a number sequence. The groups of numbers and letters either side of the equal sign are called expressions. What are they called? Excellent, they're called expressions. So if we have a look at this example here, we can see that either side of the equal side, whether it's just the B or whether it's the A plus 35, they are called expressions. Okay? So A plus 35 is our expression there, okay? Because it's a group of numbers and letters. Now I want you to look carefully at how the expression has been represented using base 10 equipment. Do you remember at school we have our base 10s that we often use? Well, let's have a look at how we can use it here when we're looking at function machines. You'll see here that where we've added 35, we've got 3 10s and 5 1s. So we know that A, whatever A is, plus our 35 will give us B. So that's where we're using our base 10s to represent what we know all of that will be equal to. So when we put all of those together, we'll get the same as the number that we have in B. Now, before we go on to the rest of our lesson, I want you to have a go at writing down some key vocabulary which we've just discussed. So formula, value, variable and expression. Make sure you're confident with these words and what they mean, because I'm going to be using them a lot throughout our lesson today. Pause the video whilst you write those down. So, it's a quick reminder that a variable is the symbol for a number that we don't yet know. Formula is a mathematical relationship or rule expressed in symbols, and a value is the amount something is worth or represents. expression is an algebraic expression, comprises both numbers and variables together with at least one arithmetic operation. Okay, so the expression would be on the left side of this equal sign. And I've labelled some of the other numbers as well so that you understand exactly what it is what they're called and their role. The constants are the numbers that we do know. Okay, that will not change. Those are the numbers that we do know. The 4 is coefficient because it's dependent on our variable. Okay. So remember, last week we talked about how when we have a letter and a number which are multiplied together, when they sit side by side, instead of writing it like this, 3 times a plus 5 equals b, instead it can be written as 3a plus 5 equals b. We don't need that times symbol between them, but the number must go first. So, quick recap of something we discussed last week. When do we use brackets in maths? I want you to pause the video here and think about why and when we need to use brackets, and tell someone in your household. Fantastic. We use brackets in maths to show that the usual order of operations should not be followed. It shows that a particular operation must be carried out first. So we use brackets to show that instead of going division, multiplication, addition, subtraction, instead of doing that, whatever's in the brackets must be done first. So that might mean that subtraction is done first because it's in the brackets. So brackets help us to show that the order, that whatever's in the brackets must be done first. So a quick reminder of what we use in our school. We use BidMaths to help us remember the order of operations. So we've got B brackets, I indices, D division, M for multiplication, A for addition, and S for subtraction. Now it's your turn. I would like you to have a go at drawing the expression that represents the function machine formula. So if this is our function machine, A times 2, and then we know it's going to total B, how would you write that? Pause the video here and write that down. Super. It would be written, we know that we've got 2 A's because we've got A times 2. So that's just A added to itself. So that could just be written as 2A. So 2A equals B. Could we write this as A2? No. The number must be written first. So it must be written as 2A. Well done if you managed to get that. Now let's try another one. Draw or write an expression that represents this function machine formula. How would you write this down? Pause the video and write it down. Fantastic. This would be written, we know we've got A together with our 10, together with our 12. So we've represented 12 using a base 10, and we're using the ones as well to represent our 12. So A and 12 together equals B. So that would be written A plus 12. A plus 12 equals B. We can only place the letter and number beside each other for multiplication. Okay, so we couldn't in this case write 12A because that would mean 12 times A. But this is 12. This is A add 12 or 12 add A. So we have to write that addition symbol between them. Draw or write an expression that represents this formula. How could you write this one down? Fantastic. We can see here that A times 3 means that we've got A added to itself 3 times. So therefore, A times 3 plus 4 equals B would be written 3A, remember we've got to put our number, then the letter, 3A plus 4 equals B. Well done if you got that one. Let's try another one. Have a look at the function machine shown on screen and write down the formula. Write down an expression for this formula. Super. So if you drew the expression, you would have written it as a plus 2 times 3. So we can see that each a has 2 added. Okay, a add 2 times 3. Because we're going to have, that number is going to be multiplied by 3, so we need a plus 2 and then times it 3 times. Times it by 3. So that would be written, that could be written as a plus 2 in brackets, because you need to do that first. We can see that in our function machine, a and 2 were added together first and then multiplied by 3. So we use our brackets to show that we need to complete that part first. So a plus 2 and then times by 3. And that gives us b. A can be given a value in order to test whether the answer would be the same. So if you want to see whether this is accurate, then give a value. You might give a the value of 7. So we could see 7 plus 2 would be 9. 9 times 3 equals 27. So we'd write that just as we have done with when we didn't know the value, when we had our variables in there, but now we know our constants, we can put those in and we can say, yep, it does work. Okay, so test it with different theories and see if it works. Then maybe try that by writing it in a way where you didn't have the brackets there. Is your answer any different? And if so, then hopefully that will help you to understand why the brackets are so important. Now have a look at this picture shown on screen. What could the missing functions be? So if our input is 9 and our output is 48, think about what the missing functions could be. How many possibilities can you find? Pause the video here and try and find as many as you can. Fantastic. So you could have had 9 times 4 plus 12, because we know that 9 times 4 is 36, and 36 plus 12 equals 48. But that's not our only answer that we could have had. We could also have had 9 times 5, which gives us 45, and then 45 plus 3, which is 48. We could have had 9 times 3, which equals 27, and 27 plus 21, which equals 48. And we could have had 9 plus 3, which gives us 12, and then 12 times 4, which is 48. You might have even found more than those, and I'd love to hear if you did. Now let's have a go at some function machine reasoning. If I input an unknown number into this function machine, and the number that comes out, I then put back into our function machine again, for my final output to be 5, then what was the unknown number that I inputted at the beginning? I want you to pause the video here whilst you have a go answering this question. Fantastic. Now let's go through the answer together. Hopefully you remembered that if we only know the output, then we can use that to help us by using the inverse. So if 5 was the number that we got, then what is it that we need to do in order to go backwards? Well, divided by 3, we need to find the inverse, which is multiply. So we're going to multiply by 3. So we know our starting number, or our finishing number, was 5. So 5 times 3 gives us 15. Then that 15 was our input the second time, but we need to go back around again to work out how much it was initially. So we put that 15 back into our function machine and we times that by 3. So we're going to multiply our 15 by 3. What is 15 multiplied by 3? Fantastic! It's 45. So the unknown number at the beginning was 45. Well done if you managed to get that one. I'd like you to have a go at completing one of the sheets shown on screen. You do not need to complete all 3. So you can complete whichever level difficulty you feel most comfortable starting at. Or for some of you, you can go straight on to our Diving into Mastery challenge and complete the work that's shown. You'll find the worksheet shown on screen is the one that you'll need to complete. So you'll need to think about how you're representing the problems and writing your expressions, writing a picture to represent the expressions and then writing that down. And then there are some problems on the second sheet of that task where you then need to work out whether a statement is true or false and explain your reasoning. So especially those of you that I've spoken to and I've said, your target is reasoning, then I'd like you to make sure that you complete those reasoning tasks, exploring and finding how they found those answers. Please remember to email us your work at the Year 6 email address shown on screen. Have a great day. Bye-bye.